primitive types. They are integers, floating point numbers, booleans, characters. Probably you're already interested. What is the difference between primitive and reference types? There are many differences between them, and we'll learn all of them as we keep learning Java. But the main difference is that primitive variables store the actual values, whereas reference variables store the addresses of the objects they refer to. The primitive types in Java are analogs to the simple types found in most non-object-oriented languages. If Java object-oriented language, why then we still need to use primitives sometimes over objects and reference types? There is only one reason for this. It's efficiency. Making the primitive types into objects would have degraded performance too much. As you become more mature programmer, you will find how to use properly primitive types and reference types. But right now, let's review each primitive type in detail. Here is the table which will help you to learn and understand all primitive types. You can find next columns here: type name, size, minimum value, maximum value, and wrapper type. Primitive wrapper class is wrapper that encapsulates or wraps primitive data types so that these can be used to create objects. Why do we need this? Objects might have their own behavior and methods. We will use objects in Java collections, for example. The simplest example is that primitive type int just storing value in the variable. Integer not only storing value, but has its own behavior. For example, integer object can compare itself with other integers, which provides necessary application programming interface to create self-sorting collections. This is just one example. From this table you can see that main difference between simple integers is the amount of memory allocated for the variables. This also impacts value range of each primitive type. Taking into account that data in computer stored in binary format, the amount of bits allocated to the variable tells us what range of data we can store in it. We will learn number systems in the next lessons, and you will understand why in 1 byte, which is equal to 8 bits, we can store values from -128 to 127. You can see that 2 bytes allocated for short, 4 bytes allocated for int, 8 bytes allocated for long. If we are talking about floating point numbers, then we need to know that for each float variable 4 bytes are allocated, and for double 8 bytes are allocated. The interesting thing how much memory we need to allocate for boolean value. The right answer would be here that size of the boolean is platform dependent. Why? Because to store true or false, which in binary format 1 or 0, it's enough even 1 bit. The problem is that not always you can reserve exactly 1 bit for the variable. Most likely this will be 1 byte. Characters. We need characters to be able to describe all symbols of Unicode. Cyrillic, special characters, etc. We have 2 bytes for char primitive type. This gives us the range from 0 to 65,535. Each value will represent the sequence number of character according to Unicode table. You might be wondering why short type also have 2 bytes allocated but have different range of values. In Java you can't declare signed or unsigned variables. This is managed on JVM level. So char has the same amount of bytes allocated, but just because it's unsigned, it has different range. Probably you already heard that Java is strongly typed language. Part of Java's safety and robustness comes from this fact. What does it mean? It means that every variable has a type, every expression has a type, and each type is strictly defined. Also, all assignments, including parameter passing to the method call, are checked for the type compatibility. The Java compiler checks all expressions and parameters to ensure that the types are compatible. In case of any type mismatch, programs simply won't be compiled. We will also learn in this lesson how type conversion works in Java. So what is variable? Variable is a piece of memory that can contain a data value. You can see that each variable has data type. Even when you create variable with var keyword, compiler identifies type of this variable. For the variable name usually used nouns started from the small letter. You can't use keywords for the variable names. What are keywords? For example, int, byte, short, class, public, package, these are all keywords. Keyword is a word with a predefined meaning in Java programming language syntax. I will share with you a link to all keywords after this lesson so you could learn them. There is no need to go over each of those right now. Now let's practice. We'll take a look how to declare variables of specific types in Java. For this lesson I created a new class with name primitive types in the package primitives. Let's declare a variable of specific type. Byte b equals 1. So here is variable declaration, short s. And here is variable initialization, s equals 2. You can declare an initialize variable in one line, int I equals 3. Long L equals 4. Let's proceed. Here is a char variable, char C equals A. You can notice that characters literals annotated with single quotes. Boolean literals only true and false. Boolean bool equals true. And now let's create float variable. Float f equals 1.2. Compilation error. What's wrong? If you would hover over value, you will see the reason. The issue is type mismatch. Can't convert from double to float. You should know that floating point number literals by default has type double. And you can't convert from double to float because double requires more memory allocated than float. Does it make sense now? To tell compiler that this is float, we are using F letter. You can use capital F letter if you wish, that would mean the same. Talking about types of literals, it is worth to mention that all integer literals has int type by default. Let's have a look at this example. Long L2 equals 2 billion. By the way, you can see that you can separate digits with underscore to increase readability. You can see that there is no error right now, because int literal is still within int range. But let me add few more zeros here. And you see compilation error. Why? Because literal of type int is out of range. What to do in this case? Just tell compiler that this literal has type long. How? Just put L letter at the end like this. Let's also create double variable. Double D equals 1.3. As you can see, there is no errors here. Previously we discussed that you can declare an initialize variable with var keyword like this. Var v equals 1. In this case, compiler will help us to identify type of this variable. So after first initialization, you can assign only integers to this variable. You can't assign boolean or floating point numbers, because this variable has int type right now. And now we'll learn primitive types conversion. When we are talking about primitive types conversion, just keep in mind boxes. You always can put smaller box into bigger one. That means you can always put value of 2 bytes into 4 bytes. Int I3 equals s. S is short here. You can put the value of 1 byte into 4 bytes variable. You can also convert int to char. Char c2 equals 100. In this case, char variable will be initialized with character which has sequence number 100 in Unicode table. Let's check what this character is. System out println c2. This would be D character. The same conversion rules are also applied if you have double variable with 8 bytes allocated and you want to assign to it int which is 4 bytes. Double D2 equals I3. You can assign 8 bytes long to 8 bytes double. D2 equals L. All conversions examples which we just saw are examples of widening conversion. In most cases, widening conversion happens without losing data, with some exceptions. A widening conversion of an int or a long value to float or of a long value to double may result in loss of precision. That is, the result may lose some of the least significant bits of the value. In this case, the resulting floating point value will be a correctly rounded version of the integer value, using IEEE754 round to nearest mode. If we would talk about narrowing conversion, it can't be done automatically. For example, if I would try to assign int variable to byte variable like this, b equals I3. We see here a compilation error because compiler can't convert int to byte. What we can do as programmers, only in case when we need this, we can tell compiler that we know what we do, and tell compiler to calm down, and we are sure that this is byte. Just type in parentheses byte. You can do the same way with all other narrowing conversion. You might be wondering if all integer literals have int type by default, why we don't have compilation error when we assign int literal to byte like this, byte b2 equals 10. We don't have compilation error because compiler can read literal's value during the compilation process and identify that this value is within the byte range. But if we would add additional zeros here, we would see compilation error. Now I can put byte here, but what would happen if I would try to print byte to console? Your best guess? Sysout b true. This situation called overflow. When an integer overflows, it rolls over to the minimum value and begins counting up from there. You know that max positive byte value is 127. Let's put 128 here and see what it would print to us. Minus 128. Be careful with conversion from double to long. Even despite 8 bytes allocated for double the same as for long, the integers and floating point numbers stored in different way in memory. Conversion from type double to type long requires a non-trivial translation from 64-bit floating point value to the 64-bit integer representation. Depending on the actual runtime value, information may be lost. That's because floating point numbers and integers stored in different way in Java memory. Let's consider this example. We have this long number. Let's convert this value to double and then back to long. Do you see the difference between long and double converted back to long? Just take this into account when converting long to double and vice versa. And probably the last thing which I would like to cover with you for today is autoboxing and unboxing. At the beginning of this lesson you saw that each primitive type has its wrapper type. Autoboxing is automatic conversion that the Java compiler makes between the primitive types and their corresponding object wrapper classes. For example, integer i4 equals 1. So here you can see that int was autoboxed to integer. If the conversion goes the other way, this is called unboxing. Int i5 equals i4. Here you can see that integer was unboxed to int. And now let's recap what we have learned today. After this lesson you know what primitive types are, what variables are, you know rules for conversion between primitive types, and you saw what autoboxing and unboxing is. And now your homework. Read books, read chapters about primitives, learn Java keywords, and take a look at Oracle documentation regarding primitives conversion. In this lesson we will learn with you number systems. We'll discuss today why we need to understand different number systems. We'll learn what binary, octal, and hexadecimal number systems are. And we will learn how we can use binary, octal, and hexadecimal literals in Java source code. Let's start. Before we jump to binary number system discussion, let's try to understand why do we need to know number systems. The human language consists of words and characters. This type of data is not suitable for computers. When we enter data, the data is converted into electronic pulse. Each pulse is identified as code, and the code is converted into numeric format. It gives each number, character, and symbol a numeric value, number, that a computer understands. One of the skills which is useful to programmers is understanding of relationship between number bases. You won't use binary, octal, or hexadecimal format on daily basis, but this is an important part of your general education as software engineer. Because sometimes in JDK in source code you will find hexadecimal literals, and you need to be prepared to understand the source code. I will try to explain to you different number systems with examples as easy as possible. Hope examples will help you to understand the topic. Let's start from binary number system. Binary number system radix is 2. Binary digits can only be 0 or 1. Let's take a look at this binary number. I also identified that this number has base 2. As an exercise, let's convert this binary number into decimal format, which we are all used to. To convert to decimal format, let's split these digits like this. We have ranks now, which are started from 0 and from the right to left. In each rank you have to do following calculations. Multiply the number in each rank by base of number system in the power of rank. For example, let's start from left to right. 1 is the number here. Let's multiply 1 by base of the number system, which is 2 as we discussed, in the power of the rank, which is 3 in this case. So it will be 1 multiplied by 8. After we are done with similar calculations for each rank, let's add these numbers together. Here we have 8 plus 0 plus 2 plus 1. So this number in binary format equals to 11 in decimal format. Does it make sense now? Octal number system. Octal number system radix is 8. Notice how in each of these number systems the number of digits contained within the system is name of the system. Base 2 has 2 digits, base 8 has 8 digits, and so on. Just remember that each system starts counting with 0. So let's convert now this number with base 8 to decimal format. The same algorithm. Let's draw lines to see ranks. Starting from left, we have 7 multiplied by base of number system, which is 8 in the power of rank, and so on. Let's add these numbers together. Here it is. We converted octal number to decimal. You can use online converters to verify. Hexadecimal number system has radix 16, and 16 numbers from 0 to 9, and after that we are using letters A, B, C, D, E, F, which are according to decimal number systems equals to 10, 11, 12, 13, 14, 15 respectively. Let's convert this hexadecimal number to decimal. We have base 16, and calculations are pretty straightforward for you. Now let's have a look how we can write binary, octal, and hexadecimal literals in Java. So everything is easy here. Binary, octal, and hexadecimal integer literals have different prefixes. Let's write here integer in decimal format. Int dec equals 152. This is a decimal format. If you want to write integer in binary format, just use special prefix. Int bin equals 0 b 100 11 3 zeros. Octal number started with 0 prefix like this. Int oct equals 0 to 130. and hexadecimal number started with 0x prefix. Int hex equals 0x98. You can use letters here if you want to express another value. Let's print all these numbers to console in decimal format. These variables represent the same number in decimal format. Let's recap what we have learned today. In this lesson we have learned what number systems are. We know how to convert from binary, octal and hexadecimal systems to decimal. We know how to use binary, octal and hexadecimal literals in Java. And now your homework. Hope it will be easy and fun for you. Just try to find out what decimal number is encoded in hexadecimal name of rock band AC/DC. In this lesson we'll learn more about arrays in Java. Here's our agenda for today. We'll discuss everything about arrays today, including what runtime errors might happen during interaction with them. Also we'll talk about multi-dimensional arrays. And I will show you how you can use arrays class to perform standard manipulations with arrays. Before we give definition to arrays, let's try to understand what do we need arrays for. Pretend you're implementing software for a travel agency, and you want to allow administrator to see list of people who bought trip to Spain for specific date. You need to get this information from database and group all users in one place in your program to show them to your administrator. For such purposes you can group all users in an array. So what is array? Array is an object which contains elements of similar data types and support access to them by index. Accessing each of the element in the array by its index for the constant amount of time, that's what we love arrays for. Just remember that indices in array start from 0. That means if array size is 9, the last index in this array is 8. If you want to compare arrays in Java and in other languages, be aware that there are some differences. For example, the important one is that in Java array size is fixed. Once array is created, you can't change size of an array. Now let's take a look how to work with arrays in Java source code. I prepared for this lesson before video recording, so we don't spend time during the lesson on typing code. I created this class beforehand and you can focus directly on the examples. You can declare array variable like this. Type of elements in your array, square brackets, and variable name. There is also another way to declare array variable. Type of elements in your array, variable name, and square brackets. You can use the one you would like the most, but I would recommend you to use the first declaration. In my humble opinion, it is more readable, because you instantly see that this variable is array of ints, but not like you are noticing that this variable is int, and after that you realized that this is array of ints. Now let's initialize this variable. This variable equals new, type of the elements in array, square brackets, and 10 inside the square brackets. New keyword tells JVM to allocate memory for the new object and return reference to this object. And in square brackets I indicate size of my array. This array has size 10. You can check array size with length property of the array, like this. And let's run this program. The length property of the array will tell us the size of the specific array. To get access to the element in the array, you can use its index. Let's print to console the first element of this array. Let me comment this line first, and uncomment this line. You know this command, and here we are retrieving the first element of the array by its index. You remember that index of first element in array is 0. Let's run our program. You see that the first element is 0. Why it is 0 if I didn't put 0 in this array? That is because each data type in Java has its own default value. For integers, it's 0. Let's take a look at default double value. I created an array of doubles here. Let me uncomment this line and run the program. For double, default value is 0.0. What about booleans? Here is similar example with booleans. And run the program. For booleans, the default value is false. Since primitives are not actually objects on their face in Java, then they must be initialized by default, because semantically they can never be empty. Primitive variables are not the references to objects. Each primitive variable stores a value in itself. Now let's take a look what will happen if I would use index which doesn't exist in array. You saw that this array has size 10. Then the last index in this array is 9. I will try to print to console element with index 10 in this array. What will happen? Runtime exception called array index out of bounds exception. I tried to get element from array with non-existing index. Always remember that the last index of the array is array size subtract 1, because indices are started from 0. Now I want to show you array literals. If you already know size of an array and variables, you can use array literals like this. Declare array variable first, and then use braces to list all elements of an array. Now let's talk about multidimensional arrays. Essentially, there is no such construction as multidimensional array. Technically, it's properly to say that you can create array of arrays, thus implement matrix in your program. For example, let's create array which will contain int arrays. You declare a variable first, this is int array type, and this is array. So you have array of int arrays. Here we have variable name, and this is array literal. So you use braces to declare your array, and inside this array you use array literals to instantiate other arrays. In multidimensional arrays you can get access to specific element by index of the array, that will be index of the row, and index of the element in that array, that will be column index. Just like this. Here is variable of our multidimensional array. This 0 refers to index of the array, this is our first array, and this number refers to the element in this array. So basically the first number indicates row, and the second number indicates column. Let's run this program. Here it is. You can instantiate multidimensional array specifying just its size, without array literals. In this case, I specify just array size. Let me print to console the first element of this array. It is null. Why? Because arrays are reference types and not primitives. If you have array of arrays, the default value of each array variable will be null. Because all arrays are not instantiated yet, and there is no array object in memory for the reference. I can specify size of each inner array like this. Now all inner arrays will be instantiated. And when I will print array object to console, I will see something like this. What is this, and why do we see this? We'll discuss during the learning of the OOP topic, when we will take a look at object class and default implementation of toString method for all objects. In JDK we have special methods to perform basic operations with arrays. Let me show you how you can easily print arrays to console. Just type system out println, next, type arrays, like this, and call toString method. Pass reference to the array object as argument to this method. Let's run this program. Here you can see values from this array. Here are they. And now, for example, I want to sort values in the array. Let's type like this. Arrays sort, and pass the reference to array. And now let's print the same array to console one more time. You see? Magic happened. So what does this arrays mean? Arrays is the class in JDK which contains various methods for manipulating arrays. such as sorting and searching, for example. This class is located in Java util package. Also, I wanted to draw attention to one thing, that after we wrote arrays here, Eclipse automatically added import statement on the top of our Java file. What is import statement in Java? Import statement is a convenience to the programmer and is not technically needed for the programs. With import statement, you bring into visibility certain classes or entire packages. As soon as you imported class in your Java file, you can refer to the class directly by using only class name. Here you can see that Eclipse helped me to import Java util arrays class. What if I wouldn't have this import statement? Let me just delete it. I saved the file, and you see compilation error here. Compiler can't understand to which arrays class am I referring to here, but I can tell compiler that full class name Java util arrays, and error is gone. Compiler understood that I'm referring to class from JDK here. If we are going to refer to dozen classes in our application, the import statement will save a lot of time and typing also. And also one more tip for the future. In case you see some errors in your source code, just hover mouse over error or set cursor in the place of error and press Ctrl+1 and see what Eclipse will suggest you to fix the error. In this case, Eclipse suggested me to add import statement. Just select what you need and press enter. Do you see this? Import statement for arrays type appeared again on the top of our file. I save file to remove compilation error. All basic classes such as wrappers of primitive types are included in package Java lang. Import statement for Java lang package is implicitly added by compiler to all Java files. So this declaration is redundant. You saw only two methods from arrays so far. Now I will teach you what all developers should know. You have to know how to learn and investigate source code. Just hold Ctrl button, hover over class name, and do mouse left click. If you are doing this first time in the Eclipse, most likely you will see something like this. This means you don't have source code attached. Let's attach source code together. Press Attach Source button, External Location, External File, and now please go to your JDK folder and find lib folder in it. You see I am in my JDK folder, and in lib folder which is inside JDK. We are looking for src zip file, and this is what we are looking for. Just select it and press open. OK? And here is your source code of arrays class. In JDK, in all classes you can find detailed Java documentation about each class, field, and method. That is the way how you can investigate what some specific methods do. Investigating of the source code in JDK is part of your self-education. You can find list of all fields, methods, nested and inner classes here in outline view. Also you can press Ctrl+O to see the list here in code editor. You can start typing method name and select it to navigate faster there. For example, sort of int array. And press enter. And here's Java documentation for this method. Feel free to learn documentation for other methods in the class. Let's recap together what you have learned today. We learned what arrays are and how to work with arrays. We learned default values for primitive types. In this lesson you saw how to instantiate multi-dimensional array. Now you know what import statement is used for and how to investigate source code of JDK. Also you know what Java util arrays class is and how you can